So the answers to your review, true or false? You can name a plane by a capital letter such as A. True or false? True. And the one thing that drives me insane on your companion study guides is they name planes with 4 letters, which is incorrect. At most, how many letters should you name a plane by? 3. So you either name a plane with a capital letter such as A, which is not a point in the plane, by the way, or you name it with 3 non-collinear planes in the plane. Not 2, not 1, but 3. All right, so number 2, a plane contains a finite number of lines. Do you know what finite means? It's the opposite of infinite. It's an actual number, something you can count, right? It's countable. So a plane contains a countable number of lines. True or false? True or false? It's false. It has an infinite number of lines. 2 points lying on the same plane are coplanar. So 2 points lying on or in the same plane are coplanar. True or false? Lying in the same plane. True or false? It's true. If 2 distinct planes intersect and they intersect in exactly 1 line. True or false? That is true. That's the definition of intersecting planes. If 2 lines intersect, what do they intersect in? 1 point. So then your new vocabulary word today is parallel. I think you all already know what parallel lines are. Parallel lines are in the same plane but never intersect. So if they're not in the same plane, they cannot be parallel. It is possible to have 2 lines that are not in the same plane but don't intersect. Those are not parallel lines. Parallel lines have to be in the same plane. So then circle the segments that are parallel to the x-axis. So here's your x-axis. Which of these 4 segments are parallel? Bailey, which ones are parallel? Correct. So those 2 are parallel to that x-axis. And so, Ashley, which ones are parallel to the y-axis? Would you say C, C, and AB are correct? Which polygons have 2 pairs of parallel sides? Does a rectangle have 2 pairs of parallel sides? Yes. How about a parallelogram? Why it's called a parallelogram? That's 2 sets. What about a square? Yep. What about a trapezoid? What does a trapezoid look like? It looks like this. Oh, you can't see it? Thanks for telling me now. All right, so there's your trapezoids. Typical picture of a trapezoid. These right here are your parallel lines. So a trapezoid has exactly 1 set of parallel lines. It cannot have 2. If it has 2, it becomes a parallelogram. And so we'll learn that later. If you've got arrows on a set of lines, that means that those lines are parallel. So that's new notation for you, and we'll run into that in a minute. And then the last 2, a blank consists, it should be consists, of 2 endpoints and all the points in between them. What is that? A segment or a line segment. Segment or a line segment. A blank is made up of an infinite number of points. A line. Alright, so there's your review. So flip that page and let's talk about our new stuff. So you've got 3 new vocabulary words: parallel lines, skew lines, and parallel planes. So parallel lines are already defined for you. There's 2 pieces that you need to know. They are coplanar, they do not intersect. Skew lines, however, are non-coplanar. Although they're not parallel, they do not intersect. So a skew line is 2 lines not in the same plane. They are not considered parallel even though they don't intersect. So a skew line would look like this. Here's a line right here, and here's a line right here. They're going in opposite directions of each other. Could I create a plane that would encompass both of those at the same time? They might both go through the same plane, but there's no way that I can create a plane either this way or this way, whoops, or this way. There's no way I can create a plane that has those 2 in them unless I turn one of them this way. Now they're coplanar. I could create a plane that those two are in, right? So for skew lines, you're looking for lines that typically are going opposite directions, like one's going up, down, one's going right, left. And you couldn't connect them with a plane. So that's something new and different for you. So you're going to explore that over here. One thing I mentioned that we're going to use arrows to show parallel lines. So you can see a single set of arrows right here on line AE and line BF. So you've got those single set here and here. And then you also see a double set, and so it's just like tick marks. The double set lets you know which lines are parallel to each other. So because these are double arrows, they're parallel to each other. But your skew lines in this one would look like AB and CG. So skew would be line AB and line CG. So they're not in the same plane. I can't create a plane that would go through them. So those are your skew. So then write each order phrase or symbol in the correct oval. So take all of these and put them in the correct oval. And one of them might go in an oval twice. So you decide where to go. Go ahead and put them in. Compare yours with somebody around you. See if they have the same things in the same ovals. Talk about something. All right, you ready? So with parallel lines, they are coplanar, right? They do not intersect. And then which set of these lines were parallel? The first set or the second set? The first set, right? AE and CG, but look at where AE is and CG is. I'm going to use a color here. AE is right here and CG is right here. They're on diagonal corners to each other, aren't they? Those aren't in the same plane, are they? I don't see the plane. Can you draw one in? Can't I draw a plane diagonal across here, including these sides right here, and then diagonal across here? Can't I put a diagonal plane into that box? And you have to be able to envision that, because that's a very popular question, because they know that you'll sit there and go, oh, well, they're not in the same plane, so therefore they cannot be parallel. But they are parallel, because I could draw a plane in there that would contain that. All right, so then let's look at skew lines. Unlike parallel lines, they are non-coplanar. These are not in the same plane. But like parallel lines, they do not intersect, so that's what they have in common. And then your skew lines would be the other set, CD. And so CD is right here. And then AE is right here. So one of them is going like this on the top, whereas the other one's going like this in the front. So they're not in the same plane, can't possibly draw it. They don't intersect. Skew lines. Questions about that? All right, so let's look at problem 1. I want you to answer 11, 12, 13, 14, 15. I want you to answer all the way through here, so you ought to be able to complete problem 1 on your own. And then we'll discuss it. Oh, and do bear in mind that this is what's annoying me right here. And just take out that one, and that one. That's how they should be naming the planes, is with 3 letters, not 4. Get to the bottom question. Because if you sit here and don't answer things, you're not learning. The whole point is for you to sit there and think on your own. Otherwise, I'm not going home with you to help you with your homework. All the way down to 17. If you're not sure, that's okay. It's a good time to make a mistake. So take some time right now, stop where you're at, even if you're not done, talk to somebody about where you're at. You're at stuff, that's why you can get finished, talk about that, so you've got Not necessarily. Like if you've got between any points, any three non-collinear points, yes, you always get a plane. But through any two lines, not necessarily. A, F, G. I can make one with A, F, and G. A, F, G, and D. C, F, G, and D. I can diagonal plane. They're not collinear. Oh, they're planar. So you want three non-collinear points, and that's why they're not collinear. So because they're three non-collinear, I can pick one.
So it must be like you had A right to the left of it. You added A.
Correct. Because then you would have
Really, any of those points.
correct. Except if you chose 4 points, now when you have 4 points that are non-collinear, may or may not be able to. So if I chose points A and E and points D and C, I can't make a plane for those points because A and E are going this way. D and C are going this way. I can't use those skew lines. So if you've got 4 points and 2 are on one line and 2 on the other line, and those lines are skewed, you can't make a plane. But if any 3 points, I can always make a plane. As long as it's non-collinear. Okay, so let's go ahead and talk about these. So, let me cover up my answers. So the first question, let me grab my blank sheet. First question says, in plane ADH, blank is parallel to AD. So here's AD, and this is the front face is what we're talking about. So what's parallel to AD on the front face? EH is correct, so line segment EH. And then on number 12, in plane ADB, so ADB, so it's the top plane, blank is parallel to AD. So in the top face, what's parallel to AD? BC, so that is correct. And then 13 in plane ADG, that would be, so A, D, and G connects also with F. So if I made, that wasn't very good. So if I make a line here and a line here, I now have this diagonal plane here and here. It goes diagonal through that box. So this time they're asking you what is parallel to AD. Yeah, FG. So here it is. The FG are the ones that are directly opposite going diagonal. So FG is correct. And then we want to go on to explain skew lines. So remember, skew lines, they are not in the same plane, so they're non-coplanars, so coplanars should be crossed out. Like parallel lines, they don't intersect, so you want to cross out intersect. And they are specifically in the definition termed not parallel lines, and so parallel should be crossed out. So those are the 3 things that you want to know about skew lines. So on my flashcard, I'd be making sure that those 3 things are listed out. They do not intersect, they are non-coplanar, they are not parallel, because I could ask you a true-false question on that on the test. It's very easy, because you could think that they're not parallel because they don't intersect, but they are not parallel. All right, so then, out of these 2 statements, the first statement is the one that is correct. Segments and rays can be skew if they lie in skew lines. So a line contains an infinite number of rays and an infinite number of line segments, so if they lie in skew lines, they would have to also be skew. Segments and rays are never skew, that's wrong. They are if they lie on skew lines. And then for 16, FE and CD. So here's FE and CD. So let's highlight those. FE and CD. Can I create a plane between those? Yeah, I can go from here to here. So therefore they are parallel. Oh, by the way, but that's what they're getting you to. So from the bottom to the top, so that's the second part. And then you had to answer this question. So answering the question in the sense of, well, they're skew lines because they're not parallel lines doesn't necessarily answer the question. So how are we going to answer that question? How did you answer the question? What did I do to prove that they were parallel? They're in the same plane. So you want to mention the things about parallel lines that are important. That they're in the same plane and they do not intersect. So, why are FE and CD not skew? FE and CD are not skew because you can draw a plane to contain them, or however you want to say that. That is the big difference between skew and parallel, so that's what I would be saying, is pointing out the fact that they are coplanar. If you point out the fact that they don't intersect, I could then argue with you that, well, skew lines don't intersect either. Speak a little louder because I've got that blower over here. Yes. And I would add one more word to that because they're in the same diagonal plane. So you're really, really clear. The problem with geometry is you have to be really clear and specific. Because I can, as you found out with counterexamples, I can always throw one little thing in there to throw you off. Questions about that? All right, so we're entering a new section. Now we're going to talk about types of angles. These will come back to haunt you for the rest of the year. And so there are very specific angle pairs formed when you have, don't talk while I'm talking, when you have two lines intersected by a transversal. So this right here is the transversal. You want to add a definition on here of a transversal line. A transversal line quite simply intersects two or more lines. Now today we're not going to look at if the two lines are parallel. So for today, you're going to assume the two lines are not parallel unless told otherwise. But a transversal does not have to intersect a parallel line. It just has to intersect two lines or more. So this transversal here could intersect 10 lines, or 100, or 1,000,000, as long as it intersects two or more lines. So line L and line M are not transversals because this only intersects, well, technically this intersects 2, doesn't it? Why? Isn't it going to eventually intersect M? Okay, so I could argue that all of these are transversals, but for our purposes here, you're going to look at T being the one transversal. That is T, right? All right, so then we've got some definitions. Alternate interior angles. Put each of one of these on separate flashcards. Because if you don't know them just like that, and you have to think too much about them, you don't know them well enough, and you're going to die on your task. It says exactly what they are exactly what it says. They're alternating on the interior. So if you took, and I would suggest at home that you take 2 spaghetti noodles, uncooked spaghetti noodles, by the way. You took 2 spaghetti noodles, and you would set them on the non-transversal lines. So if I obviously don't have 2 spaghetti noodles, but if I took 2 spaghetti noodles and set them here, there is an inside between the 2 lines, and there's an outside of those lines. The interior represents the 4 angles that are on the inside. So the interior here will be angle 4, 3, 5, and 6. And the angles on the outside would be 1 and 2, and 7 and 8. So you might want to note that. These right, and it says that right here on the interior. These are the interior. And then these are your exterior. They're on the outside of those lines. And believe it or not, the 2 spaghetti noodles are going to help you be able to see that, because a lot of you are very visual oriented, and it'll help you see it. So alternate interior angles just mean that they're on alternating sides of the transversal. So what would be an alternating side for angle 4? What would be an angle that's on an alternative side to angle 4? Angle 4 is on the left side, so wouldn't the other side be the right side? But angle 3 doesn't count as an alternate side. It has to be diagonal. So 4 and 6 are on alternate sides of the transversal, and they're both in the interior. Whereas angle 4 and angle 7 are on alternate sides of the transversal, but 7 is on the exterior, 4 is on the interior. Does that make sense? Bless you. So notice that the definition says non-adjacent, and that's why 4 and 3 don't count as alternate interior, because they are adjacent. They have to be non-adjacent interior angles that lie on opposite sides of the transversal. So that means that it's 4 and 6, so we're going to write that here. Let's do it again. Angle 4 and angle 6. What's the other pair? 5 and 3. So angle 5 and angle 3. We have 2 pairs. Then same side interior. They both have to be on the interior, and they're both on the same side of the transversal. So if angle 4 is one of them, what's an angle that's on the same side of the transversal but on the inside? There's only one choice. Would that be angle 5? Same side interior. So angle 5. So then angle 3. What would be its same side interior? 6. Corresponding angles. Corresponding angles are essentially the same position. So you've got a group of 4 angles that are created anytime 2 lines intersect. 4 angles. I would call, and you can turn your paper however you need to, but I usually view these as, in this group of 4, this is the upper left, upper right, lower left, lower right, and I'll turn my paper however I need to for that to happen. So there's always 4 sets of corresponding angles when you have 2 lines being intersected by a transversal. So angle 1, and what angle is in the same position here in this group as angle 1? In the upper left, which one is in the upper left here? Angle 1 is in the upper left here. Which one's in the upper left here? Angle 5, isn't that one in the upper left? So angle 1 and angle 5 go together. What corresponds to angle 2? 2 is in the upper right, 6 is in the upper right. So angle 6. Then we have angle 3. So angle 3 and which one? 7. So lower right, lower right. And our last pair would be angle 4. And which angle? Angle 8. So it's really a lot of what you're going to be doing on tonight's homework is identifying angle pairs. Make sure you're using proper notation. And make sure you're checking your answers, because you want to know before we hit tomorrow's lesson whether you understand how to name an angle. Brody, are you asleep or awake? Hard for me to tell, so sit up straight. Then we have alternate exterior angles, exactly the same as alternate interior angles, but this time we're looking at only the 4 exterior angles. So we're only looking at angle 1 and 2, and 8 and 7. So again, there's those spaghetti noodles coming into play, right? Only my pens are too fat. We've got these 4 angles here. So angle 1, which one is alternate exterior to angle 1? Alternating sides of the transversal, which would mean angle 7 or angle 2, because they're on alternating sides, but they cannot be adjacent. So angle 7 is your only choice. And angle 2, and obviously angle 8. So without looking above at what we wrote, match those. Without looking above, so I'd cover this part up if I were you, as you're doing it. All right, so 4 and 6, are they on the inside or the outside? Inside. So are they alternate interior, same side interior? Because those are the only choices. Alternate interior is correct. And then, well, I'm going to uncover those in a minute. And then 3 and 6, we did that one. Oh no, we didn't do that one. 3 and 6, both inside, both outside, one of each. Both inside, so alternate interior, same side interior. Same side. And then 2 and 6, both inside, both outside, or one of each. The minute you have one of each, your only choice is what? Corresponding. Those are the only angles where you always have an exterior match with an interior, because they will always be corresponding. Well, not always, but it's a possibility. And then 2 and 8, both inside, both outside, or one of each. Both outside. Right now, you only have alternate exterior angles as a choice. Could you have same side exterior? Sure, they just didn't mention it. So that's really what you're doing on today's homework. So look at example 2. I want you to identify the transversal and then answer questions 22 through 24 on your own. So think for yourself. Don't let me do all your thinking, or your neighbor. When you get those done, I want you to trade with people around you, kind of talk about them, especially question number 24. So chat about this group of questions. Talk. All right, so let's talk about number 22. I could argue with you that the transversal line is any of them, the way they've written it. But you need to answer going with the obvious choice. So what's the obvious choice for the transversal line? R. Because this is the one that is truly intersecting both lines. Right now it's showing the intersections. And then corresponding angles are on the same side or different sides of the transversal. So like for instance, 1 corresponds to angle what? 3. This is in the upper left, that's in the upper left on that group of 4. And so aren't they on the same side? And if you did that for each and every corresponding angle, you would find that they're always on the same side of that transversal. And then here are your corresponding pairs. So it doesn't matter what order you put them in. 1 and 3, 2 and 4, 8 and 6, and 7 and 5. Good with those? All right, so answer 25 through 27. 25 through 27. So when you answer those, I want you to talk amongst yourselves. So you can come up with what type of angles those are. Okay, so let's talk about 25. Are angle 1 and angle 3 on the same side of the transversal, yes or no? Yes. And then question 26. You were to cross out the types that do not describe angle 1 and 3. Are angle 1 and angle 3, are they on the same side? Where are we at? Oh, are they alternate exterior? Are they both exterior? Just angle 1, right? So bless you. That one's out. Are they both on the interior? No, because one's inside, one's outside, so that's crossed out. Are they corresponding, same position? Out of this group of angles, and you only see 2 out of the 4, this is in the upper left, and you only see 2 out of the 4 here, but this would be in the upper left also for this group of angles, so that does match corresponding. Are they on the same side? Are they on the same side of the transversal? But are they both interior? No. So that one's crossed out. So then that kind of answers question 27. Angle 1 and angle 3 are corresponding angles. All right, so back page. So this is your lesson check. I want you to do this on your own. We are not, and go ahead and do questions 28 all the way through 38. And then you're not going to compare with anybody because you're going to try to see if you can do it on your own. It's your own test. So I'll give you a couple minutes. Bless you. So I give you 2 more minutes. Today, sounds about right. Okay, so let's talk about these. Let's look at 28. Parallel segments. So a segment that's parallel to AB, you only have one choice. What is that? What's parallel to AB? Number 28. CD or DC, right? Skew segments, you actually have two choices. What segment is skew to HD? Here's HD. What's one choice? I hear AB. Would you agree with that? Are they coplanar? Nope. Can you draw a plane that would connect both of those? Nope. So those two are skew, definitely. So AB. What else? What's another one? FG, can you put a plane to connect those two? So that's another possibility. There actually is one more. Anything that's parallel to a skew line but is not in the same plane as the line you're trying to see what is skew to it is also skew. So isn't BC parallel to FG? Right? So that's skew as well. And then, so somebody said AB. What about EF? Could EF be skew also? Because isn't EF parallel to AB? Doesn't that work as well? There's actually 4 choices, aren't there? All right, then, I don't like the fact they named it with 4. So plane ABC is the bottom plane. What plane is parallel to the bottom? The top. So here's that one. And then we also had 2 more choices for skew. And we had or AB or the other one's EF. So those 4 were possibilities. And I put up there EF, G, or H. Any of those 3 letters would be the correct plane. So then, here's your picture that we're looking at here. So question 31, alter interior angle to number 8. Alter interior angle to angle 8. Angle 6. 32, same side interior to angle 8. Same side. Angle 3. And then corresponding angle to angle 1, upper left. Angle 3 is in the upper left. Alternate exterior angle to angle 7, alternate exterior. So it has to be 5. So there are your answers for that one. Then we had the error analysis where Carly said, I get that picture in there. Carly said that line segment AB is parallel to line segment GH, and Juan says that AB and HG are skew. Who's correct? What did you say? Carly or Juan? Carly's correct. Why? You can draw a diagonal plane through there, right? So if I took and connected these right here, there's that diagonal plane. And so they've been harping on that diagonal plane, haven't they? So note to self, don't forget if you don't see the plane that you can draw it in there. Any questions? Yes. I want you to be specific because if you can't see the plane, that's the only reason why. If the plane was already there and written, I'd be okay with you saying that, although it's not wrong. I would prefer you saying that you can actually draw it in there because you're explaining to somebody who doesn't understand why they're parallel, so think of it in terms of that way, because you can draw that plane in there, and therefore, yes, they are coplanar.